So we're going to finish up by talking about energy expenditure here. So here we're going to talk really about metabolic rate and steady state. That's really kind of the main focuses for this lecture. So metabolic rate is just how much energy is your body using. Okay, so an easy way to figure out how much energy your body is releasing is just to know how much oxygen are you using per day and how many kilocalories are you using on average or releasing on average per liter. Okay, that would be really difficult to calculate, but we can estimate it. Now, you've got two different types of metabolic rate. The first one is basal metabolic rate. And so this is just how much energy are you using if you were to lay supine, so face down, after 8 hours of sleep. Okay, so you sleep for 8 hours, and I know some of you are probably laughing as you hear this because you're a college student. You're like, when was the last time I got 8 hours of sleep? Ironically, I actually got 8 hours of sleep last night. It's weird, but it happened. Okay, basal metabolic rate is essentially how much energy do you need to survive. Now, there are several factors that can affect this. So how much fat do you have? If you have less fat and more muscle, you use more calories. Body surface area. If you've got more body surface area, you can release more heat. If you release more heat, you're going to use more calories. Okay, age. The older you get, the less calories that you use. And I'm experiencing this firsthand, and I really hate it. Okay, like I said, aging sucks. Core temperature. If you have a higher core temperature, you're going to burn more calories. Remember, temperature is just a measure of how fast molecules are using and stuff like that. Increasing temperature increases the speed of chemical reactions occur. And then stress. The more stressed out you are, the more calories you use. And so I guess there is some benefit to having finals besides just the stress that comes with it and the fact that you're done with a class. Now, we also have resting metabolic rate. This is something that's more commonly used. It's not exact. It's not an exact measure of basal metabolic rate, but it gives us an idea. Resting metabolic rate is always greater than basal metabolic rate, but it's usually pretty close. Okay, and so typical adult uses between 1,200 and 2,400 calories of energy per day. Excuse me. Hopefully you didn't hear me sneeze there. Anyway, but the average metabolic rate is somewhere between 18 and 3,000. And in some cases, some athletes exceed 10,000 calories. All right, you ought to, if you haven't, just hear an offensive lineman, especially the pros, talk about how much food they have to eat just to maintain their weight. Okay, with all that they're doing, it's a massive amount of food. And for some of them, it's very difficult to do. It's like they're either practicing or eating, which sounds like a difficult existence, actually. Okay, but resting is just kind of what you typically use. So how does this relate to submaximal exercise? Well, if you exercise, you're going to require more calories, and so you're increasing your energy requirement. The nice thing is your metabolism, or the amount of energy you need, increases in proportion to the exercise intensity. Okay? It's a linear relationship. And when we're at submaximal intensities, we can actually determine how much energy you're using. But in order to do that, we have to reach that steady state, which we were talking about last time. So this is where your body's adjusted and it's meeting the demand. Okay, so your heart rate and your cardiac output and your breathing and everything else is constant, and you're meeting that demand. So in essence, you can make a strong argument that you're essentially in homeostasis. Okay, that's not entirely accurate, but you're getting really close. This takes time to occur, just depending on how big of a jump and how intense the exercise is. So this can take anywhere from 1 to 5 minutes. Now, when we're talking about steady state and submaximal conditions, the reason RER and estimating energy works is because a lot of these other things aren't true. When we reach maximal conditions, we experience a metabolic acidosis. Okay, we're releasing a lot of hydrogen ion, and in order to buffer that, we start breathing more. We hyperventilate during maximal exercise. This causes our RER to be higher than what it actually is. Okay, and as a result, it's hard to actually estimate how much energy we're actually using. If you have a low-carb diet, it's hard. It's going to be hard to know how much energy you're using because your RER is going to be inaccurate because you don't have lots of glycogen stores. And so then you're going to start relying on proteins, and proteins, you have a different oxygen requirement than carbs do. And so if any one of these 5 conditions is true, you can't use RER to estimate to estimate fuel production or energy release. That's the better word. Okay, and especially in number 1 and number 2 and number 4, all those kind of go together, and this can cause your RER to exceed 1 because you're releasing more CO2 than you're actually producing, and so that'll make your RER higher than what it actually is. So the last thing that we want to talk about is VO2 max. And so this is the maximum amount of oxygen that your body can use. Okay. Notice that as we increase in intensity, it doesn't matter if you're sedentary, normally active, or conditioned, or even an elite endurance athlete, everybody falls along this line. Okay. But we'll get to a point where we can't use any more oxygen. Okay. And we'll talk about what these units mean on the next slide here. But notice that, like in the sedentary person, right, they hit this 30 at this point, but they still are able to increase their intensity. Okay, and so the question is, well, why does that happen? Well, this is just VO2 max is just a measure or an indicator of how much energy you're using from aerobic systems. When we exceed max, when we exceed the intensity where we hit VO2 max, we're not using any more oxygen even though we're working harder, but now we're relying on those glycolytic systems, okay, those anaerobic systems to help us go a little bit further. And when those two systems together aren't enough to provide enough energy, then you're done working and you stop, okay? Now with VO2 max, we can look at it in terms of absolute, which is just how much oxygen are you using, liters per minute. Okay, and so we've got that here, all right? And then we've got relative, which is we standardize this by taking into account body weight, all right? So I'm likely going to use more oxygen than any of you in the class just because I'm bigger than most of you. I'm taller, okay, that sort of thing. I weigh more, most likely, than most of you. And so just that makes it a lot easier for me to use oxygen because I have lots more need, all right? But that doesn't necessarily mean that I'm more fit than a person, all right? And so we can standardize this and take it and use a relative number. And all we do is we take this absolute number, we convert it into milliliters, so this 5 liters a minute now becomes 5,000 milliliters, and then we divide it by body weight, okay? And so let's just say that someone has an absolute VO2 max of 5,000 milliliters per minute. They weigh 100 kilograms. Well, now their relative value would be 5,000 divided by 100, which gives us 50 milliliters of oxygen per kilogram of body weight per minute. Okay. When you get around 50, that's where you're starting to get into someone that's in pretty good shape. I've been as high as about 55, but I have seen people that are in the mid-70s when we're doing a VO2 max test. So that is where we're going to end for this first day of week 10.